Hi everyone, I'm just going to go through these 6 practice questions we did on trig derivatives. So starting with this first one, I think it's really helpful to either add in these parentheses or rewrite your trig function because this is going to remind me that I have to use the chain rule and take the derivative of the inside and the outside. So starting with the whole original function, I'm going to take the derivative of cosecant of 5x, and I know the derivative of cosecant is negative cosecant. The inside stays the same, so 5x times cotangent of 5x. And then I need to take the derivative of the inside of that parentheses. So if I take the derivative of 5x, that's going to be 5. So I would just rewrite this, put that 5 in front, so I get the derivative is equal to negative 5 cosecant of 5x cotangent of 5x. So it seems like a few common misconceptions here are, one, not putting in this set of parentheses, then you're missing this 5 in your answer. So if you don't also take the derivative of the inside or of whatever that trig function is, you're missing a step. Also, we always want to, when we take the derivative of this entire function, so the derivative of cosecant 5x is going to be cosecant 5x times cotangent of 5x. Some people had this as y prime of, let's say we remembered to take the derivative of the inside, cosecant x, cotangent x. So we're missing the 5 here. The inside is always going to stay the same. So think when we did the chain rule, I take the derivative of the outside, leave the parentheses the same, then I take the derivative of the inside of those parentheses. Alright, so for number 2, these parentheses are already here for me. If you want to highlight them to remind yourself, that's probably a good idea that I'm going to use the chain rule again. So the derivative of cotangent of 4x to the 6th is going to be negative cosecant squared. And remember that inside parentheses stays the same. So of 4x to the 6th. Then my next step, which a lot of times we forget, so make sure you highlight that, add that in. Now I need to take the derivative of the inside. So the derivative of 4x to the 6th, using the power rule, is going to be 24x to the 5th. So I would rewrite this, move this 24x to the 5th to the front, but remember I'm not changing the inside of the parentheses. Derivative of cotangent 4x to the 6 is going to be cosecant squared. 4x to the 6 stays there. Okay, and some people, a misconception here, were doing the power rule again with this 2 in the exponent and kind of bringing that down to the front. But remember, I'm not taking the derivative of this function I have here. I'm taking the derivative of cotangent, which is cosecant squared. So I don't need to do anything further with that exponent there. And here for number 3, again we have those parentheses. Highlight them because I will have to do more steps here. So taking the derivative of this whole outside function, we know the derivative of sine is cosine. That 3x plus 1 stays the same. Then I need to go in and take the derivative of the inside. So the derivative of 3x plus 1 is just 3. Okay, and some people here, again, this does not change. This doesn't become cosine of x. The derivative of sine of x is cosine of x. The derivative of sine of 3x plus 1 is cosine of 3x plus 1. Some people even wrote cosine of x times 3x plus 1, but I don't need this here twice. It's not the cosine of x times 3x plus 1, it's cosine of 3x plus 1. This always is going to remain the same. And then my last step would just be to take a derivative of that inside piece, which is why I'm multiplying by 3. Alright, and down here for number 4, again, I think it's really important to rewrite some of these original functions so we could see what rule we're using. So when we don't have parentheses, you could throw those in, but also when I have an exponent, I probably want to rewrite it so it's on the outside so it's clear I'm doing the power rule. So if I'm just rewriting my original function, f of x is secant of x, and it's that whole function raised to the 3rd power. Now this kind of makes it clear that I'm going to bring that 3 down to the front, and subtract 1 using the power rule. So my first step is going to change this to 3 secant of x squared, right? And then we know we also need to take a derivative of the inside. So the derivative of secant x is going to be secant x tangent x. Okay, and again, and if there was a random number here like secant of 2x, this would have a 2, this would have a 2. Then we would have to use the chain rule again to take the derivative of that, but that doesn't happen here with this question. We'll do some of those tomorrow. So the last thing I could do, if you think about this here, I could rewrite this as f prime of x is 3 secant squared of x. We usually write that with the trig functions times secant of x times the tangent of x. So secant squared x times secant of x, that's going to give me secant to the third of x tangent x. Okay, so I would always rewrite these, put that exponent on the outside so it's clear that I'm going to use the power rule. And for number 5, if you want to put your parentheses here, and if you think about it, we're always using the chain rule and taking the derivative of the inside, but when I just have an x in there, the derivative of the inside is 1. So we're still technically doing the chain rule, we just don't write it or show the steps there because the derivative's 1. So that's why we need to be careful on other questions like number 1 and number 3, that whatever the trig function is, I need to take the derivative of the inside. So this is a straightforward. We know the derivative of tangent is secant squared of x, and we know the derivative of cotangent is negative cosecant squared of x. That one is done. Technically, I could take the derivative of the inside here, but both of them would be times 1, so that's why I don't have to worry about it for number 5. Then last one for number 6. So there's a few things I would do first. This combines both ideas that I covered on those earlier questions. So f of x, let me rewrite this as cosine of 2x, adding in those parentheses to remind me that I have to use the chain rule. And then sine of x squared, moving that squared to the outside, reminding me I have to use the power rule. So now we're kind of combining both rules. So my first step, if I'm just looking at cosine of 2x, I'm going to take the derivative of cosine is negative sine, the 2x stays the same, and then the derivative of the inside, right? So just the derivative of 2x is 2. I'm going to put this second part down here so I have enough room. So now if I'm taking the derivative of sine of x squared, remember my first step, that 2 is going to drop down to the front, so I'm going to have 2 sine of x, and subtract 1, my power is just going to be 1. Then I need to take the derivative of the inside. So what's the derivative of sine of x? Cosine of x. Okay, so there's a few steps to follow. I always check my parentheses. Did I take a derivative of this whole function? Yes. Did I take a derivative of this function? Yes. This whole function? Yes. Then this function on the inside? Yes. So I would always start with the biggest function and keep working your way in. Make sure you're taking the derivative of everything. So we can kind of clean this up to get our final answer. So the derivative is going to be negative 2 sine of 2x plus 2 sine x cosine x. All right, so those are the 6 practice problems we were working on. I'm also going to post this answer key just as a file, so please let me know if you have questions on any of these.